Good morning, students. Welcome. Welcome back to the chemistry class once again. So, in the morning, this is a fine morning, and in this fine morning, we will be discussing about chemistry, but chemistry, of course. Now, if we go back today's class, before starting this class, if we just think about it, that what we have done in the last few weeks, the classes, they were basically on what they were on language of chemistry, about chemical changes, about reactions. So language of chemistry, I discussed rather with the very first line, that how chemistry speaks. That means the words of chemistry. The second, after continuing with this chapter, after continuing that how I'm discussing that how chemistry speaks, the various words, the various accents, the symbols, what they use, what chemistry use to speak out, to inform others, to interact with others. We have discussed, we have learned, we have adapted that language. The next, we dealt with it once we have understood, once we are comfortable with that language, then we moved on to chemical reactions, which is basically that what are the various, that where this language will be utilized. Chemistry is speaking certain language, but the application of that language, that what this language is all about, what is the utility of that language, where this language can be utilized, and what information can be derived from that particular language. All these things we dealt with, we have read, we have discussed in the past few weeks. But today, in this class, I welcome you all, that today we will do, or rather, I'll tell you a story. I'll tell you a story which is basically a fact. That means we will go back to history now. The historical facts, the things which happened long years back. And those stories, how such stories are related to us, how such stories have benefited our lifestyle, or benefited our living in the modern times. If we are able, if we know the origin, if we know the source, then the entire process of studying, then the entire process of learning a particular thing becomes more interesting. We can automatically see that it will become a more of a picture, a more of a movie type thing. Then that is, that from the origin, from the source, that how it kicked off, and till now, how everything went out, it progressed, and we are standing right now in the present times with all the things we are having, how that evolved, the evolution. It will be a splendid journey, I must tell you. Seriously, it will be a beautiful, splendid journey. Okay? I'll start today's story going back to the times of 6th century BC, a long time back, probably from the recent times, 2600 years ago. Long time back, civilizations were there, right? People were there, and developments, their lifestyles were going on. The kingdom was there, kings were there, administrators were there, and philosophers were there. During those times, people were not addressed by the term scientist. People were not addressed, that means learned scholars. They were not addressed as scientists. They were addressed as philosophers, great thinkers of those times. Great thinkers, that means people who can think beyond boundaries, who are capable of thinking beyond limitations, and who are capable of telling something which foresees something which others are not able to think, which others are not able to realize. So, those were philosophers. One of such philosophers, one fine day, he took some food, as if definitely every day he used to eat, and every day he was eating. But suddenly one fine day he was eating, took the food in his hand and started to eat. But nobody knows what happened on that particular day, that suddenly he realized, it came to his mind, that he was unable to break the food after a certain point of time. We know that this man, he was eating, as you can see, he was drinking and he was eating, and after a certain point of time, while he was eating the food, he realized that he was unable to break the food after a certain point of time. With his hand, as well as after chewing, there was something, the food was inside his mouth, and the food was inside, on his hand, because that one, he want to eat that one. But after a certain point of time, that food was not breakable. He was unable to break that one. Break means I want to divide that food into smaller pieces. So that limitation came up, and when he realized that he was unable to break that one, he thought that there must be something, there is a limitation, and he tried that one with not only with food, but also with other substances. And he found that after a certain point of time, that food was not only the food, the other substances also was not breakable. Breakable means, over here, it's not breakable, as if that is beyond the capability of that person. Beyond the capability of that person. What he did then? This led to the development or the evolution of the concept of matter. This led to the development of the concept of matter. Matter concept evolved. And when the matter concept of matter evolved, along with that, he also termed the smallest particle, after which he was unable to break that substance, whether it is food or whether it's other substance. When he was unable to break that substance, the limitation, that particular he termed as Anu. In Hindi, it's called Anu, and it's basically an Indian word. It was basically an Indian word derived from the Sanskrit. It's called Anu. And later on, this idea of this concept was later on evolved, led to the foundation stone of the concept of atoms. So this term of Anu led the foundation stone of the concept of atoms. Now you must be interested that who was this man who actually led the foundation stone of the concept of atoms. And by this time probably you may have understood that what this chapter is going to be and what the details we can find it out regarding what details we are going to deal with regarding this chapter. That great man who led the foundation of the concept of atoms was the great Indian philosopher Maharshi Kanad. Maharshi Kanad was that great Indian philosopher who led the concept of evolved the concept of matter, and he coined the term Anu, which was later we all now read as known as atoms. This concept of Maharshi Kanad was later strengthened by, and before going to that, I welcome you to the world of atomic structure. So, with this, I welcome you to the world of atomic structure. The theory of Kanad, Maharshi Kanad, was verified or strengthened by two Greek people, Leucippus and his student Democritus, between 460 to 370 BC. So this was of the 6th century BC, and this was of the 3rd century BC. That is, the Democritus, that is, two Greek people, they were Greek philosophers, of course. So Leucippus and his student Democritus, they strengthened this theory of Maharshi Kanad, and they also suggested that matter after a certain point of time becomes indivisible and it cannot be broken, and that those small particles are known as the term that coined atomos. They coined the term atomos. This, after their philosophy, many years have passed. After this philosophy, many years have passed, centuries have passed, and finally, in the 19th century, that means in the early 19th century, John Dalton, his first scientific atomic theory came in the year 1808. So in the early 19th century, John Dalton's first scientific atomic theory came into existence. So John Dalton, and he proposed also the theory about the structure of atoms. The first scientific theory about the structure of atoms. With John Dalton's theory, there was a revolution which took place in the world of scientific discoveries and experiments. What was John Dalton's theory? That was the first one, as I said. What was John Dalton's theory? John Dalton's atomic theory, he first stated, his first point was, matter consists of very small and indivisible particles called atoms. That means matter is made up of particles. A big substance, anything. We read about matter, or rather we know what matter is. From class 7 to 8, we're in class 9 now. So, we have read about matter, and those matter is made up of small particles, very small particles. Why this term very small? Because those small particles we cannot see with our naked eyes. Those are invisible also. It cannot be seen with the naked eyes. And those particles are indivisible in nature. Indivisible means it cannot be broken. It cannot be broken, and hence indivisible, not divisible. That means we cannot divide that one. And those particles, the term atomos was reframed and it's called atoms. What was the second point of Dalton's theory? He stated that atoms can neither be created nor it can be destroyed. He stated that atoms, we cannot create atoms. So atoms cannot be created. Nature can create atoms, but we are not nature. So this statement is applicable for human beings. That's a human limitation. That we cannot create atoms. We cannot destroy atoms. We can not create atoms. We cannot destroy atoms. That was the second point of the atomic theory of Dalton. The next, atoms of an element are all identical in nature. Atoms of an element are all identical in nature. If you remember about matter, then, and if you go back to class 8, the chapter elements of the pure substances over there was a point with elements that elements are made up of identical species or identical particles. Identical species or identical particles. And those identical species and identical particles are basically, they belong to one particular substance only. So based on that, similarly, atoms of an element are all identical in nature. So every element, all elements, their atoms are identical with each other. Atoms of different elements combine in different numbers to form molecules. Small numbers. So that means atoms of different elements, or atoms of, it can be of same element also. Atoms of different elements or atoms of the same element, they can combine together to form molecules. The next, atoms of two different elements combine in simple ratios. Simple, it will be whole number ratios. Though Dalton didn't specify that one, but that was Dalton's point. That Dalton specified that atoms of two different elements combine in simple ratios to form compounds. This statement was later on revised, and two terms were added, and it became atoms of different elements combine in simple whole number ratios to form compounds. But Dalton, during that time, he was unable to specify that one. The next, Dalton also stated that atoms are the smallest particle to take part in a chemical reaction. Wherever the infrastructure, the facilities available to Dalton, he made another point that atoms are the smallest particle of a particular matter, and that smallest particle only will take part in a chemical reaction. Okay. With the discovery, with the Dalton's atomic theory coming into existence in 1808, but along with Dalton, several other scientists were constantly carrying out experiments on matter to discover, to identify, to study the different properties of matter, to trying hard if matter can be broken down, or what other information that can be derived from the very core, from the very inside heart of a particular substance, a particular matter. And with that theory, and with that several informations came up in the year 1886, 1911, 1932, 1909. It goes on. But before I move on, before highlighting that what exactly happened during those particular times, those particular years, you can see a picture. You can see a print of what Dalton stated. This is basically the explanation put forward by John Dalton about atoms, about molecules, about atomicity. We know by this time what atomicity is. So, a molecule with 3 atoms, a molecule with 4 atoms, a molecule with 1 atom. So, all these things, as Dalton specified in his writing, in his book, that those actual things are there in front of you. You can check it out. From the Dalton's point, based on the Dalton's point, theory, atomic theory. So in the year 1886, not 1886 rather, maybe it's 1897, Sir Joseph John Thomson, in 1897. In 1897, Sir Joseph John Thomson, he discovered that atoms are not the smallest particle of a particular matter. What he discovered? He discovered that atoms are made up of electrons. Atoms contain electrons. Atoms contain electrons. And as you can see over there, that's Sir J.J. Thomson busy with his experiment. Later on, as the time flew, in the year 1909, or rather 1911, Eugen Goldstein in 1886, and followed by Ernest Rutherford in 1909, They discovered protons. They discovered protons. Another particle of inside atoms. This is Eugen Goldstein, followed by, this is Rutherford, Ernst Rutherford. But with the protons coming into existence, Ernst Rutherford was not alone. Ernst Rutherford was not alone. There were two other person more. They were Ernest. There were two other persons. Ernest. I'm forgetting the name. All right, you can check it out, that one. Two other scientists who accompanied Rutherford to lead to this interesting and fantastic discovery. Later on, with experiments growing up, with experiments going all over the world about studying matter, the different properties, the particles coming into existence, and all the interesting features of substances and matters are getting highlighted. In year 1932, a fantastic discovery was made by Sir James Chadwick, and he discovered the neutrons. He discovered the neutrons, for which, this is James Chadwick, and for which later on he got the Nobel Prize for his experiment and for neutrons. So with these particles coming into existence, and electrons, protons, neutrons, new theories came up, and about the structure of an atom, how an atom looks like from inside, and all these fundamental things when it was coming up. Those fundamentals and those theories were basically the development or re-verification or remodification. It's a remodification or modification of the Rutherford's atomic theory. Because Rutherford, in the year 1911, he proposed the first atomic model theory, which came into the in front of the scientific community, the scientific world, in the year 1911. According to Rutherford's atomic model, an atomic model looked like with a central nucleus, having positive charge, and though it stated electrons over here, but it's a modified Rutherford's atomic model, but not the initial one. It's a modified Rutherford's atomic model. But the first atomic model theory which came up, they didn't have these electrons. They have that some particle cloud is revolving. Something is revolving around the nucleus, and the nucleus that was termed by Rutherford, and then he stated that it contains, that means the central part, there is a charged mass, and surrounded by something is revolving around that central part. That was the first atomic model that came in front of the scientific community and the scientific world. Let me show you something interesting one. Sorry. I want to show you one video. Watch this video out.
The plum pudding model of an atom was one of the most widely accepted models all over the world for understanding the structure of the atom. However, several experiments performed by scientists to study the atomic structure showed astonishingly different results. They were contradicting the plum pudding model. This led many scientists all over the globe to reconsider the structure of an atom and study it again. Around the year 1911, a British physicist, Ernst Rutherford, carried out the famous gold foil experiment. He did this to understand the structure of an atom. The experiment was carried out by Rutherford along with Hans Geiger and Ernest Marsden. The experiment he performed was a breakthrough in the field of chemistry which helped him understand the structure of an atom in a more accurate manner. This is how the setup of his experiment looked like. As we can see here, he used a source of alpha particles locked in a lead container with a very small slit. This ensured that the alpha particles only came out through a small opening and travelled in a straight line. But why did he select alpha particles in the first place? Well, the alpha particles were having high energy and were heavier as well. So if we say the atom is like a pudding of positively charged particles with electrons embedded in it, then the particles will pass straight through it. This is obvious because the heavier particles will pierce through the lighter pudding structure of the atom and pass through it. This is what Rutherford thought. For this reason, their greater mass and energy compared to the protons made him choose alpha particles for the experiment. Next, he used a very thin gold foil on which the alpha particles would bombard. Why did he choose a gold foil? Well, a really thin gold foil was estimated to contain approximately 1000 atoms. Lesser the atoms, more convenient the experiment would be. Lastly, are we able to locate the circular band with a gap here? What could this be? Well, this is a screen. A fluorescent screen that would help us detect the radiation. That means the screen will glow or emit fluorescent light whenever alpha particles will hit it. So this is how the track of alpha particles can be traced. Now we're all set to understand how the experiment worked. The alpha particles were emitted from the element present in this box. These directly hit the gold foil. Now what should happen ideally? As we know, the Thomson's model suggested that an atom is a sphere of positive charge with negative electrons embedded inside it. That means it is expected that the alpha particles will pass right through the atoms and hit the detector straight. And why so? Because the mass of alpha particles is heavier than the mass of positive charges. That means they should directly hit the atom and move ahead through it. Only a very small deviation would probably be acceptable in this case. But is this what he observed? Not really. He was astonished to get unexpected results. What results did he get? He found that most of the fast-moving alpha particles passed straight through the foil and hit the detector. However, some particles got deflected by small angles. And lastly, to his astonishment, few alpha particles also rebounded. Now, how can this be possible? These three observations made Rutherford think that the plum pudding model is not really correct. Based on the conclusions he had, he put forward the new hypothesis explaining the structure of atoms. What were his conclusions?
So, I hope you have watched this video and you like that one. Since today is the last class, probably the last class before the summer vacation, so I will stop over here with today's class. I know that there will be lots and lots of questions in your mind. There will be lots and lots of questions in your mind. What's this, what that? But for that, you can do a research regarding your questions, or you have to wait till the next class, or you can ask me some questions I will answer, and some definitely I will keep it for the next class. So till then, we meet after summer vacation fresh with a new energy, new class, and discussing from the point where we stopped over today. So till then, thank you and take a very good care of yourself.